All right, let's get into it. Today, we're going to grab our hard hats and look at something pretty fundamental, the architectural blueprint of a database. We're going way beyond just using data to see how the actual structure that holds it all is built from the ground up.
I mean, really think about it. We talk all the time about querying data, pulling it, analyzing it, but where do the tables and columns we use every single day even come from? How do they exist in the first place? And that's the big idea for today. I want you to stop thinking about this as coding for a second and start thinking about it like architecture. Before you can move in any furniture, which is your data, you absolutely need a solid, well-designed blueprint for the house itself.
So, the special language we use to write this blueprint, it's called Data Definition Language, or DDL for short. These are the specific SQL commands that don't actually touch the data. No, their job is to create, modify, and define the very structure where your data is going to live. And, just like building a real house, our first step isn't putting up the walls, not even close. Before any of that can happen, we have to secure the property and get the whole construction site prepped and ready to go. In the world of SQL, this breaks down into three essential first steps. First, you've got create database. That's literally like buying your plot of land. Then, show databases lets you take a step back and survey all the properties you own. And finally, the use command. Well, that's like planting a flag in the ground and declaring, right here, this is where we build. Now, one really important thing to remember here is that when you create that database, its name has to be totally unique across the whole system. Just think of it like a street address, right? You can't have two houses with the exact same address in one city. This command carves out that dedicated space, your own private plot of land, for your data's new home. Okay, so we've got our plot of land. Awesome. Now it's time to start putting up the walls and actually building the rooms. In database terms, these rooms are our tables, and they're where we'll eventually store all the specific bits and pieces of our information.
So check this out. This is a blueprint for one of those rooms. We're calling it the customer's table. We define every feature of the room as a column, like ID, name, and age. And then we have to specify what each of those features is made of, its data type. So an integer for the ID, some text for the name, and so on. And just like in real construction, you've basically got two main options here. You can design a room completely from scratch, defining every single little detail yourself, or, and this is a really cool trick, if you like a design that already exists, you can just make a copy of its blueprint using the like command. It's so useful for creating a new table with the exact same structure as one you already have. But of course, blueprints are almost never final, are they? Our needs change, we might realize we need to knock down a wall, add a window, or hey, maybe even demolish the whole structure and start over. Well, in SQL, we have some seriously powerful tools for exactly these kinds of renovations. The alter table command is your all-in-one digital renovation toolkit. It's what you reach for when the initial structure is already built, but you realize, something needs to change. With this one command, you can add, remove, or completely change the features of any room in your database. Think of it like this. Using add column is like deciding, hey, this room needs a new window. Using drop column is like tearing out a closet you just don't need anymore. And modify column, that's like changing the flooring, maybe switching from carpet to hardwood by changing a column's data type. And then there's the demolition crew. That's drop table. This command doesn't just remodel, it completely obliterates a table and everything inside it. This is, without a doubt, the most powerful and, let's be honest, the most dangerous command in our entire DDL toolkit. And I really want to pause on this because it is so important. Once a table is deleted, then all the information available in the table would also be lost forever. Let that sink in. There is no undo button. There's no oops, my bad. Using drop table is a final, irreversible decision. It's gone. Forever. So a house isn't just walls and floors, right? To be livable, it needs rules. It needs plumbing that actually works, electrical wiring that's up to code, and locks on the doors. In our database, these essential rules are called constraints. And that's really the heart of it. Constraints are not optional suggestions. They are the fundamental, non-negotiable building codes for your data. The database itself will enforce these rules automatically, 24/7, to protect the integrity and the quality of the information you're storing inside.
Okay, so let's start with two of the absolute basics, the primary key and not null constraints. A primary key makes sure that every single record, every item in your room has its own unique ID number, no duplicates allowed. And not null is a simple but incredibly powerful rule that just says, hey, this piece of information is required. It cannot be left blank, period. And we can get even more clever with our rules. The unique constraint is great for things like email addresses. It ensures every single value in that column is different. And the check constraint lets you create your own custom rule, like telling the database, hey, whatever number goes in this age column, it has to be greater than or equal to 18. But maybe the most powerful rule of all isn't one that just governs a single room. It's one that actually connects multiple rooms together, turning a collection of rooms into a truly functional, interconnected house. And that brings us to the foreign key. Look at this. The customer ID in our orders table is a foreign key. It points directly back to the ID, the primary key in the customers table. This creates an unbreakable link. It's like the hallway that connects the orders room to the customer's room. It makes it physically impossible to have an order in your database that doesn't belong to a real existing customer. It's all about logical consistency. So, after all this building and remodeling and rule setting, why does spending time to get the blueprint right matter so much? Well, it's because it creates a solid, reliable, trustworthy foundation for everything that you're going to do next. When you boil it all down, this whole toolkit, create, alter, drop, and constraints, it's all about one thing, the structure. It's all about building the house properly before anyone or any data ever moves in. A well-defined structure is what makes your data trustworthy, efficient, and, in the end, actually useful. So I'll leave you with this final thought to chew on. If all of your valuable data is the furniture, the appliances, the people living inside this house you've built, what happens when you eventually discover that the blueprint was flawed from the very beginning? Thanks for tuning in.